By the expectation value of a random variable x, we mean the average outcome of x if the experiment was repeated infinitely many times. We use for the expectation value the expression e of x, and often we write briefly the Greek letter mu. Let us explain this idea with the following experiment. We roll a die where two sides are a 1, three sides a 2, and one side is a 5. And let x, the random variable x, be the number of pips obtained in one roll. Now the question is to find the expectation value of this random variable x. So this means we have to find the average of x if we repeat this experiment infinitely many times. Well, let us reduce infinity to 600 and let us assume an ideal world. The probability of the outcome 1 is 1/3, and in an ideal world, where of the 600 times it will be exactly 1/3 times 1, this means it will occur 200 times. So we can fill in the rest of these columns, and we get these numbers here. To find the average of x, this means the average number of pips obtained in our experiment, we have to find the total number of pips in the 600 rolls, and then we can calculate its average. So let us find how many pips we got due to the result 1, due to the result 2, and due to the result 5. Well, obviously, the number of pips obtained due to the ones is just 200, since 200 times a 1 occurred. The outcome 2 contributes 2 times 300, since 300 times a 2 occurred, and the outcome 5 contributes 5 times 100, since 100 times a 5 occurred. So the average number of pips per roll is, since we roll the dice 600 times, 1300 divided by 600, or 13 divided by 6, so approximately 2.16. Let us now look at the contribution of each outcome to the average. So this means the outcome 1 contributes a 1 in 200 out of 600 times. So it contributes 1 times a third. The outcome 2 contributes a 2 in 300 out of 600 times, so 2 times 300 divided by 600, so 2 times 1/2. And outcome 5 contributes 5 in 100 out of 600 times, so 5 times 100 divided by 600, or 5 times 1/6. And we get the average as the sum of these three numbers. So when we look now at these numbers here, what do we have here? Actually, we have the outcome 1, the x1, let's say, times its probability 1/3. Here 2, that's the x2, times 1/2 its probability. And here we have the outcome 3, 5, times its probability 1/6. And so we see now what the formula is for the expectation value. By generalizing this, the expectation value of random variable x is x1 times p1 plus x2 times p2 plus x3 times p3, and so on. So this means we have to look at all outcomes and multiply them with their probability, and then sum up these products. And using sigma notation, we can write this as the sum of xk times pk, for k being from 1 to n. Let us use this now to solve example 2. We're given here this wheel of fortune, and when we turn it, we will win 7 francs if it ends up in this sector, 6 francs if it ends up here, 3 francs if here, and 0 francs if it ends up here. And we have to pay 5 francs for turning it once. The question is, should we play the game or shouldn't we? And the way to answer it will be just to look at the expectation value. Let us find first all the possible outcomes. Well, one way to look at it would be just to say the possible outcomes are 0, 3, 6, and 7. But let's take the net gain or losses as outcome, which means here we have a loss of 5 francs, so -5. Here we get -2. Here we have a win of 1, so 1, and here we win 2 francs. So this is the set of all our possible outcomes, and now let's find the probabilities for each of this outcome. Let me start with the probability of getting a 2, which means ending up in this sector here, and hence is 1/4 the 90 degrees divided by 360 degrees. Now complete the other probabilities on your own, calculate the expectation value and find the interpretation. Stop the film now. And here comes the result. The probability of a 1, so getting this sector, is 150 divided by 360, so 5 divided by 12. And to find the probability for a -2 and a -5, we have to find this angle alpha. The total angle here is 360 degrees minus the 90 degrees minus 150 degrees. So remains 120 degrees, and alpha is then half of it, so 60 degrees. And we get the probability for getting here this sector, so -2 as a net loss is 60 divided by 360, 1/6, and then obviously the same for the net loss, -5 here. The expectation value is now the probability of each outcome multiplied with the outcome, so -5 times 1/6, -2 times 1/6 again, then the 1 times 5/12, and the 2 times 1/4. And then summing up all of these products, we get in the end -1/4. What is the interpretation hereof? Well, the average loss per game is 1/4 franc or 25 rappen. So you should probably better not play the game, since if you play it a lot, on average you will lose per game 25 rappens. Here is an important definition in probability theory, since we like to talk here a lot about games. So we call a game fair if the expected gain or loss is 0. So the expectation value of this random variable x describing the outcome of this game has to be 0. We will use this in example 3. There is a box with 13 red, 8 green marbles and an unknown number of blue marbles. To play the game, you have to pay 10 francs, and then you can draw blindly one of the marbles. You will get 12 francs if you get a red marble here. You get 3 francs if you get one of the 8 green marbles, and you get 20 francs if you get a blue marble. How many blue marbles are there in the box if the game is fair? Let us look at the second question here after having solved the first one. Our sample space is -7, 2 and 10, namely if we get a green one, in the end we get -7, if we get a red one we get 2, 12 minus 10, and if we get a blue marble we get 20 minus 10, so 10. In total, there are 21 plus x marbles, the 13 red, the 8 green, and the x blue ones. The random variable x is the net gain or loss, so you can now find the expression for the expectation value of x, and since we know that it has to be 0, you can calculate small x, the number of blue marbles. Do that on your own, stop the film, and here comes the result. The expectation value is probability of each outcome times the outcome. So we have -7 times its probability. -7 we get for the green marble here. So -7 times 8 divided by the total number of marbles. So -7 times 8 divided by 21 plus x. Then the 2 times its probability. That's the one for the red marble. There are 13 red marbles, so 2 times 13 divided by 21 plus x. And the 10 is when we get a blue marble, which means 10 times there are x blue marbles, so x divided by 21 plus x. And now we set that equal to 0. We multiply both sides by 21 plus x, so the fractions disappear here. We get this simple equation, and the result is that x is 3. The number of blue marbles is 3 if the game is fair. Now that we know that there are 3 blue marbles in the box. Let us look at the second question here. We draw 8 marbles from the box with replacement, and the question is, what is the probability to get exactly 5 red and 3 blue ones? This means probability here. You can solve that on your own, so stop the film, and here comes the result. The probability that the first marble drawn is red is 13 divided by 24. The probability that the first 5 marbles drawn are red is 13 divided by 24 to the power of 5. The probability that then the next marble drawn is blue is 3 divided by 24, and the probability that the next 3 marbles will be blue is 3 divided by 24 to the power of 3, and we have to multiply these probabilities. This is now the probability for getting first 5 red and then 3 blue marbles. However, we're not interested in this outcome only, but in any outcome with 5 red and 3 blue ones. So we could also have first a red, then a blue, then another 4 red, and then 2 blue ones. Well, for this, the probability is the same like this one here. It's just the second outcome. The question is, how many of these outcomes are possible with the same probability? Well, we're drawing 8 times, and 5 out of these 8 times should be red. So there is the 5 possibilities where to draw the red one is 8 choose 5. So we have 8 choose 5 times this probability, and we get that this is approximately 9.7%.